Good afternoon, Anurag. Good afternoon, Rishika, Janvi, Rajlakshmi, Shravani, Alice, Anushka Burate, Narayan, Samruddhi, Kalapati, Aniket. Good afternoon to all of you. So we already started the lesson motion. So I already told you that in general, if anything is changing position, we call that thing is in motion. For example, you know that this fan is moving, so I say the fan is in motion. And if anything is not changing the position in general, in everyday life, we say it is at rest. For example, this CPU, this monitor, it is at rest because it is not changing position. But according to science, if we say that fan is in motion, that is wrong. We have to relate it with something. For example, fan is in motion with respect to me. For example, if the car is changing the position, I will tell car is in motion, but that is incomplete with respect to me, because the same car is not in motion with respect to driver, with respect to passenger who is sitting behind the car. Okay, so telling just that car is in motion, that is wrong. It is in motion with respect to me. The same car is at rest with respect to driver, with respect to passenger. Okay. Now, in the same manner, this monitor CPU is at rest with respect to me. The same thing is in motion with respect to the person changing the place, because he is changing the position with respect to these items. So it is in motion. So mere saying that this thing is in motion, it is wrong. Motion and rest, they are relative term, they are not an absolute term. We have to relate it with reference point. For example, chair is at rest with respect to me, chair is at the motion with respect to moon. Okay. This we already studied, and we have seen that in the body as a whole moving from one place to another. We call it as a translatory motion. Okay, translatory motion. Now here we will find some body they are moving straight. We have classified this translatory motion into three. Rectilinear motion. When the body is moving in a straight path, we call it as a rectilinear motion. For example, the bullet of the gun, it will go straight. It is a rectilinear motion. For example, the chalk is falling down. It is coming straight down. It is a rectilinear motion. For example, car is going straight on the road. Okay, car is going straight on the road. What we call it as a rectilinear motion. So going straight. So we will find the rectilinear motion. Rectilinear translatory motion. Because here we will find the body as a whole moving from one place to another. Okay. Then another is if the body is moving in a curved path. Okay. It is going not straight but in a curved path. Okay, such kind of motion we call it as a curvilinear motion. The curved path is moving, we will call it as a curvilinear motion. Okay, for example, now I have a weight tied to this thread. I will move like this. I will move like this. So this weight, it is moving along the curved path. So it's a curvilinear motion. Okay. For example, we will find cycle moving on a curved path, curvilinear motion. Now, the next is we will find another translating motion where the whole body is moving from one place to another, random motion. Now, yesterday night I gave you example. Yesterday afternoon, in night also I have seen. You just see any bulb in the night time. You will find many insects, they are moving randomly. We don't know at what point they will go, at what time. Any time they can move at any point. So such kind of movement, it is called random motion. Okay, so this is very good example. You can observe players playing football, they can pick the ball where ball will go, we can't guess. It will go at any point at any time. So such kind of motion we will call it as a random translatory motion. Okay, so other is random motion. This we have already studied under translatory motion, rectilinear motion, curvilinear motion, random motion. Okay, then about rotatory motion. Rotation. Now, when the body is moving around itself, around the axis, it is called rotatory motion. For example, you know that fan, the blades of the fan, they are moving around itself in the rod, okay, around the rod. So such kind of motion, it is called rotatory motion. For example, if I go like this around myself, just in imaginary axis passing through me, so it's a rotatory motion. And the body is moving around its axis. For example, you know that Earth, it is completing one rotation in 24 hours. So it is movement of the body around its axis, around itself. It is called rotatory motion. Okay. Then you know that merry-go-round, fairy wheel in pairs you might have seen. Is the blades of that merry-go-round with the chair at the tip. It is moving at a high speed. All of you might have experienced that merry-go-round, fairy wheel. It is moving at a high speed. The blades are there at the tip. There in chair. You have to hold the chair and you have to sit there, and it will rotate very fast. Okay. So these all examples where we will find the body move around itself, around its axis. It is called rotation. Okay. For example, now in this as a whole the body is not moving from one place to another. Now in translated motion what we have seen, the body as a whole moving from one place to another. The car as a whole moving from one place to another in a straight path, rectilinear motion. In a curved path, curvilinear motion. And if a thing is moving randomly at anywhere like a ball, hockey ball, moving while playing, so it's a random motion. Ball as a whole moving from one place to another. But here the body is remaining at the same place. The fan is not going here from here to there and from there to there. It is remaining at the same place, moving around itself, around its rod axis. That is a rotatory motion. Okay. Now if merry-go-round, it will not move from here to here. It will not jump from here to here. It will move around. The blades will move around itself, around the central axis. axle, isn't it? So we will find it is a rotatory motion. Steady it will move around itself only. It will not go from one place to another. In translative motion, the body as a whole move from one place to another, either in straight curve or in a random motion. So such kind of movement where the body moves around itself in its axis, it is called rotation. Okay, this we have seen. Then circular motion. Now you know that suppose this is sun and earth is moving around the sun, that is completing one full circle at 365 1 by 4 days. Okay, such movement in a circular path is a circular motion. For example, moving around the earth in approximately 27 days. That is a movement in a circular path. It is called circular motion. Suppose this is the ground and here is the track. Now athlete is moving, running from around in a circular path. It's a circular motion. You are riding bicycle in a circular path. It's a circular motion. For example, here in the center is there. I am moving around this chair in a circular path. It's a circular motion. You are riding bike in a circular path. It's a circular motion. Moving the car in a circular path. It's a circular motion. Okay. Then we will find oscillatory motion. Okay, now yesterday also we have seen, I have explained. This is the mean position. Now, this weight suspended freely with the help of a thread. It is moving to and fro about the mean position. This is mean position. It is going to fro about the mean position. Such to and fro motion about the mean position, it is called oscillation. What do we call that? Oscillation. To and fro motion about the mean position. For example, this is the weight is going to, this is the mean position. Coming to the mean position, then again it is going fro, coming to the mean position. Such to and fro motion about mean position. It is called oscillatory. Okay, now what is one oscillation? When from means, for example, this is the weight suspended with the help of a thread. This is the mean position. It will go here. It will go here. It will go here. It will come here to the mean position. From mean position, it will go to the here, go, and it will come to the mean position. Like that, this it will go here to the point. From O, it will go to the A. From A, it will go to the come to the mean position. From O, again it will go to the B. Again, it will come to the mean position. This is one complete oscillation. Okay, and we will find it repeats one oscillation after fixed interval of time. It takes fixed time to complete one oscillation. So such kind of motion, it is called periodic motion. the motion which repeats itself after the fixed interval of time. It is called periodic motion. For example, you know that Earth it takes 365 1 by 4 days for Earth to complete one revolution around the sun. So after every 365 1 by 4 days, it completes one revolution around the sun. So it takes fixed time. It repeats motion which is repeated after the fixed interval of time. That is called periodic motion. For example, revolution of the sun, earth around the sun, and the satellite moon, it is revolving around the earth, completes one revolution after every approximately 27 days. Okay, such motion which takes fixed time it is called periodic motion. Which repeats itself after a fixed interval of time, it is called periodic motion. Oscillatory motion is a periodic motion because it takes fixed time to complete one oscillation. Okay. But don't think that every oscillatory motion is a periodic motion. Now, here, right, left, right. My hands are also moving to pro mean position, moving to pro to mean position pro, mean position to, but it is not taking fixed time to complete one oscillation. Isn't it? So it's non-periodic motion. Periodic motion means it repeats itself after a fixed interval of time. Okay, such motion it is called periodic motion. Then you will find that sometimes what happens at a time one or two or more motions are taking place at a time. For example, you know that Earth is rotating around itself. It takes 24 hours for the Earth to complete one rotation. Okay, like that it is rotating. At the same time, as a whole it is, suppose this chair is sun, as a whole it is moving, it is revolving around the sun. Means rotation as well as a whole movement, that is revolution. So here what we will find, both the motions are taking place at the same time. Such many examples are there. You will find at the same time two or more motions are taking place. Okay, for example, you know ball rolling down from height. When the ball is rolling down, it is moving around itself. Means rotation. But along with the rotation, it is changing place from one place to another as a whole. Means translative motion is also taking place. Translative motion, rotation. So such many examples are there. At one time, two or more motions are taking place. Now here regarding oscillatory motion, one more example I want to give you. Now this, you have seen that this is the rate suspended freely. Now it is oscillating. From mean position going to then coming to mean position pro, coming to mean position. Now such kind of motion you might have seen in rubber band. Now here you will find this is the weight suspended freely. Now rubber band, both the ends are fixed, but when you plug it or when you plug the string of guitar or banjo, okay, what we will find, this will go to then pro and come to the mean position again. Okay, so here also such kind of movement oscillation is taking place, but it is taking place very fast. So such kind of fast oscillatory motion is there. We will call it as a vibration. Vibratory motion, vibration. This is oscillation. Okay. For example, if I have here, I think Professor has kept here. Tabla, you know, tabla it is here. Okay, now I will not read. Tabla when you are the we will find it is connected from circumference. Here, when we are reading it, this it is also showing to and fro motion, fast to and fro motion. That is also called or vibratory motion. Okay. So thank you very much. Now your maths period is there. Write down homework. Write down homework. Shardul Bhatkar is asking one doubt. Very good, beta. You should ask doubt. What is the difference between oscillatory and periodic motion? See, oscillatory motion means to and fro motion about the mean position. For example, it will go here to come to the mean position, flow, again it will come to the mean position. So such to and fro motion, it is known as oscillatory motion. Okay, for example, sitting. I am also sitting in Zula, you are also sitting in Zula. What we are doing? You are moving to, then coming to the mean position, flow. Mean position. To and fro motion about the mean position, it is called oscillatory motion. Now, what is periodic motion? Okay, he is asking Shardul, I am hearing. Periodic motion, it is the motion which repeats itself after a fixed interval of time. For example, you know that Earth completes 365 1/4 days to complete one revolution around the Sun. After every 365 1/4 days, it will repeat the same motion and it will take fixed time to complete that. Okay, so such kind of movement, it is called periodic motion. For example, Earth, it is rotating around itself. It takes 24 hours for Earth to complete one rotation. And after every 24 hours, it will repeat, it will take again 24 hours to complete. After again 24 hours, it will complete its motion and it will repeat again. So such kind of motion which repeats itself after a fixed interval of time, it is called periodic motion. For example, oscillation also you might have seen pendulum clock. It will take fixed time to complete one oscillation. Okay, such kind of motion it is called periodic motion. So thank you very much. You please write down this answer and send the photo. Now your math period is there. Nigam madam is taking. She may be waiting for you. So I will stop here. Thank you.